Welcome folks. In this video we are going to look at science paper 1 for the year 2019, and we are dealing with a paper that was written by the external candidates. Now let's have a look at the first question from section A. Question 1. The diagram below shows 4 identical metal bars placed between 2 wooden blocks on a ruler. Okay, then the question is, what is the diameter of one metal bar? So how can we answer this particular question? So let's look at this. So we know that the shaded area indicates the wooden block. Then this is our first metal bar, second metal bar, third. Then we have our fourth metal bar. Now we want to find the diameter of one metal bar. So how can we solve this? So let's look at where we have. So we can see that this is where let's count from here. So say one dimension, we have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we can see that the total diameter, the total distance for these 4 identical metal bars will be equal to, so say total distance is equal to 12 centimeters. Now in order to find the diameter of one, we are going to divide by 4. So let's divide by 4. So 4 into 12 will get 3.0 centimeters. So this is the diameter of one metal bar, which is our answer is C. Then we can also find the same total diameter, if possible, of the 4 metal bars. So let's do this. If this is 0, 1, 2, 3, so this is 4. So 4, then here, if we just follow the actual numbers, if this is 15, this is our 16. So to find the total distance for these 4 metal bars, we can find the difference between 16 and 4, which is giving us the same number, 12. Then we divide by the 4 metal bars, which is giving us 3.0. Then we move on to question 2. Which of the following would change the period of oscillation of a pendulum? So we're looking at the factor that may affect the period of a pendulum. So the first one, thickness of the string used. No, this does not change the period of a pendulum. Then B, we have mass of the pendulum. This does not change. Then C, length of the pendulum. So this is our answer. We know that the length of the pendulum can change the period of a pendulum. Now let's move up to question 3. The diagram below is a graph showing the movement of a car over a period of 70 seconds. What distance was traveled by the car while its speed was decreasing? So let's look at this diagram. So here we have the speed is increasing. So this is not the distance that we are looking for. Then at this point where the line is horizontal, this is a constant speed. So the speed when this vehicle was decreasing is here. So this is the distance that we are solving for. So we have decreasing velocity. So we want the distance for this shape that I've shaded. Now let's go back to question. So the diagram below is a graph showing the movement of a car over a period of 70 seconds. So if this is our 60, then here is our 70. Now how can we find the distance? We know that the shape that we have here is a triangle, and a triangle is given by this formula, half BH. So what is the B? The B is the value from here up to here. Then our height is this distance here up to there. So this is our height. So we can see that the height, we'll get it from the y-axis. So we see that our height will be 20. Then our b will be the difference between 70 and 60. So now let's do calculations. We have half times our b, which is 10, then times our height, which is 20. So if we cancel 2 here is 1, 2 here is 5. So 5 times 20 will give us a 100 meters. So this was the distance that was covered. So the answer is just A. Now we move on to question 4. The diagram below shows a 200 grams object on a frictionless surface acted upon by 3 forces. Okay, then let's look at it. So there is a 6 Newton force which is pulling this object toward the left. Then we have 2 forces which are pulling this one in an opposite direction on the right side. Now let's look at the question. Which of the following is correct about the acceleration and the direction of movement of the object? So let's look at, we'll first begin by finding the acceleration. So we use the formula from the Newton's second law of motion, which is net force is equal to mass multiplied by the acceleration. So to solve for acceleration, we'll divide by mass, also here by mass. So the acceleration will be the net force divided by the mass. Now let's look at how can we find the net force. So net force will be given by this. So we can see that we are going to have the sum of these 2 forces. So these 2 forces will be added since they are pointing in the same direction. So say 2 newtons plus 5 newtons. Then we'll subtract the 6 newtons. We can see that if you look at the y-axis, this one is pointing in the negative x-axis. So this will be subtracted. And the easiest concept is whenever you have 2 or more forces that are pointing in different direction, for you to find the net force, you just have to solve for the difference. So 2 newton plus 5 newtons. So the sum of these 2 newtons will give us 7 newtons minus 6 newtons. So here we are going to have 1 newton as the resultant force. So we have the 1 newton. So we can now put this 1 newton here. So we have 1 newton divided by, what's the mass? So the mass is 200 grams. Now remember, whenever you are dealing with this formula, the mass should be in kilograms. So say 1 kg is equal to 1,000 grams. Then we have 200 grams. Then we put x here. We cross multiply. 100 grams by x will give us 100 grams x. Then here we are going to have 200 grams by kg. So we divide by this 1,000. Also here by 1,000 grams. So we can see that this will give us a 0.2 kg. So maybe the simplest form is whenever you are converting mass from kg to 100 grams, to grams, multiply by 1,000. Then from grams to kg, you need to divide by 1,000. So that's what we've done. Now, after we have our mass according to the way we want, so we'll divide by 0.2. So 1 divided by 0.2 will give us 5. So 5 is our answer for acceleration. So the acceleration is 5 meters per second. Then what will be the direction? So the direction, you can see that the net force is giving us a positive 1. So this means that this object moved to the right. So the answer is C. The acceleration is 5, the direction is to the right. Then we go to question 5. Why would a mechanic prefer to use a longer spanner to loosen a nut than a shorter one? A longer spanner would, the first one, add grease to the nut, B, give a greater turning effect. So the answer is the longer spanner will give a greater turning effect. As a result, only a less amount of effort will be applied in order to loosen a nut. Now we move on to question 6. A drum of water of weight 2000 Newton is rolled up a plank of length 2 meters onto a platform 0.8 meters high. Then the question is, what is the work done on the drum against gravity? So whenever there is this condition against gravity, the distance that you are going to use is this distance, which is perpendicular. So do not use the slanting distance whenever you are told against gravity. So what is the formula for work done? We know that work done can be calculated by the force times the distance. Now, whenever we are looking at the weight of something against gravity, where there is force, we are going to put the weight. Then the distance, since it's perpendicular, you use the what? Height. Remember, weight times height is same as the force times the distance. So the force is 2000 times the height is 0.8. So you know that if we multiply this number, we'll get 1600 newtons as our answer. So the answer is just C, B. Then question 7. A crane lifts a 600 kg mass through a vertical height of 12 meters in 18 seconds. What is the crane's power output? So let's look at the formula for power. So power is equal to work done. So work done over time. So the kind of work that was done, it was through a vertical height, so it was against the gravity. So the height, we know that the height is 12 meters. So now how can we find the work done in this? So the work done for this one, we just have to calculate the potential energy. So we know that the mass is given this number, 600 times the gravity is also given 10. Then the height is 12. So we have 600 times 10 times 12. So I'm getting 72,000 joules as our work done. So whenever you have something like, whenever you are given a vertical height and a certain mass, and you want to find a question that requires you to have work done, remember to find the potential energy. So half power is equal to 72,000 over the time is given 18 seconds. So we divide by 18. So if we divide by 18, we are getting 4,000 watts. So remember, power is given in watts, and power is defined as the rate at which work is done. Then we move on to question 8. The diagram below shows a wheel and axle not drawn to scale, used to raise a load of 28 newtons by a force of 40 newtons. If the radii of the wheel R, capital letter R, and axle, small letter r, are 70 centimeters and 5 centimeters respectively, what is the velocity ratio of the axle and the wheel? So how can we find the this number here. So for us to find the velocity ratio, we'll say velocity ratio is equal to the capital R, which is the radius for the big circle, divided by small letter r. So the radius for the big circle is 70, so we have 7 centimeters over 5 centimeters. So we'll say centimeter will cancel, then we'll say 70, then we divide by 5. So the final answer is just 14. So this is our final answer here. So that's what you are supposed to do whenever you are given 2 radii. Then we move on to question 9. The diagrams below shows a bimetallic strip before and when it is dipped in a liquid of temperature -20 degrees Celsius. So this is telling us that this was a cold water because of the temperature there. Then before dipping, we can see it was straight. After it was dipped there, then we can see that it is bending. Now we can see that the metal, after bending, the metal B is inside, then the metal A is outside. So which of the following is correct? Then A, metal A is a poor conductor of heat than B. No. Then metal A contracts more than metal B when cooled. According, we can see that metal A is outside. Then C, metal B is a better conductor of heat than metal A. No. Then D, when cooled, metal B contracts more. So that is making sense, because since it has to do with a negative temperature, definitely we are looking at cooling here. We move on to question 10. A bicycle pump contains 70 cubic centimeters of air at a pressure of 1.0 atmosphere and temperature of 70 degrees Celsius. What is the pressure when the air is compressed to 30 at a temperature of 27? So here we are dealing with an ideal gas equation, since the all 3 factors were changing. So say PV is equal to T. So this is what I can advise you to master this, because you can make any formula out of this. You can make the Charles law, Boy's law, even Lusak's law, even the ideal. Now for the ideal, we can see that no factor was constant, so the 3 factors were changing. So let's divide by T, so that even here we will divide by T. So whenever we divide, we'll know that PV over T is equal to 1. Now where there is 1, we are going to put the same thing. So this is PV over T is equal to PV over T. Then we say 1, 1, 2, 2, 2, 2. This should be 1. Now remember, whenever you are given a temperature in degrees Celsius, remember to convert into Kelvin. So say temperature in Kelvin is equal to temperature in degrees Celsius plus 273. So the first temperature that we are going to convert is 7 plus 273. This will give us 280. So that is our temperature 1. Remember, the first information refer. So this is our volume 1. Then this is our pressure 1. Then this is our temperature 1. So let's substitute. What is pressure 1 is just 1. Volume 1 is 70. So for volume, it's okay whether given decimeter cubic or centimeter cubic. Do not worry with a volume. Then temperature 1, we can say that it's 280. Then is equal to pressure 2. What is the pressure? So we are solving for P2. Then what is our volume 2? So the volume 2 is this one. We can see that the volume changed from 70 to 30, it decreased. So have a 30 here over temperature 2. is 27. We are supposed to convert this one as well, so let's do that. So the temperature in degrees Celsius is 27 plus 273. So according to my calculation, I'm getting 300. So over 300. Then we can cross multiply. So 280 times 30, I'm getting 8,400. We have, this is 280 is temperature in Kelvin, then centimeter cubic, pressure 2. Then we'll do the same. So 70 times 300, I'm getting 21,000. Then we know that if we multiply by 1, it's the same, so 1 atm, then cubic centimeters, Kelvin. So let's divide by 8400 kcm. Anyway, do not, if you want, you can just exclude the units here. It's okay. Our key point is just the numbers. So if we divide by this, then we can see that if we divide by k will cancel this. We have, so what is 21,000 divided by 8,400? So according to my calculator here, I'm getting 2.5 atm as my final answer. So this is our answer here. Then we go to question 11. The diagram below represents positions at one particular time on a longitudinal wave, which position are one wavelength. So for whenever you are dealing with a longitudinal wave, for you to make one wavelength, you need to move from one compression to another compression, or from one rarefaction to another rarefaction. So that's what we want to look at here. So from W to Y, it's one wave. From X to this position here is one wave. From Y to Z, it's also one wave. So here we have wavelength, also here we have wavelength. So let's look at the multiple choices. W and X, no. W and Z, no. X and Z, no. Y and Z. So our answer is D. Then question 12, which of the following sound frequencies has the highest pitch? So pitch is considered as one of the qualities of sound. Then the pitch depends on the frequency. We know that the higher the frequency, the higher the pitch of sound. So here we just have to look at the sound with the highest frequency, which is our answer is just direct here, a D. Then question 13, the diagram below shows a ray of light from air into a rectangular glass block. Okay, then we can see that here, this is our incident ray, then this is our normal. So we have our normal line, or normal ray is the same. So the angle in between the incident ray and normal line is what we call angle of incidence. Then we have this reflected ray. So the angle between the normal ray and refracted ray is what we call angle of refraction. So if we look at the question, which of the following equations can be used to calculate refractive index of the glass? So the symbol for refractive index is small letter n, and is given by, you divide the ratio between sine I with sin r. So let's look at what is the angle on sin I. We can see it's 1, so this is sin 1 over our r is 3. So over sin 3. So we want something like this, so we can see that our answer is just A. Then in question 4, the diagram below shows how an image is formed from an object placed in front of a converging lens. Okay, the diagram is drawn to scale. So whenever we are told drawn to scale, meaning we are dealing with actual measurements. Now there is this 1 centimeter represents 2 centimeters. Okay, so this is a scale. Then what is the magnification? So we know that the magnification can be given by 5, or it's a ratio between the height of an image and the height of an object, or the distance of an image divided by the distance of an object. So the object is here, our image is here. So let's look at the height. So magnification is equal to height of image over height of object. Then let's look at the height of image. This is our image. So from here up to here, we are told that if this is 1 centimeter and this is 2 centimeters, so the whole height here is 4 centimeters. We know that 1 centimeter represents 2 centimeters, so the height of an image is 4 centimeters over here. We can see that if this is 1 centimeter, so according to the scale we have 2 centimeters, so over 2 centimeters. So if we cancel this, this will give us 2.0 as our answer, which is our C. Then also you can use the distance of an object and that of an image. So this is our optical lens. Then this is, so we can see that if we count, we have 1, 2, 3, 4 and half, so 4.5. So 4.5 is the distance of an object. So let's count from here: 1, 2, 3, 4, 5, 6, 7, 8, 9. So this can be given 9 over 4.5. We still get 2.0. Then you have question 15. A negatively charged rod is held close to but not touching an insulated metal sphere. Okay, which diagram shows the charges that are induced on the sphere? So before we look at multiple choices, let's look at the nature of this. So you can see that the nature of this, it has negative charges. Now the metal sphere, we can see that here it's neutral. So since it's neutral, the charges are distributed evenly. Now after we bring this and this negative charged rod, the positive charges will be attracted to the negative, while the negative will be repelled. So this is what we are looking at here. So which multiple choice agrees? So our answer is A. Number 16. A small heater operates at 12 volts, 2 amps. How much energy will it use when it is switched on for 5 minutes? So how do we calculate the energy consumption or energy dissipated? So energy is equal to voltage times the current multiplied by time, which is same as the energy is equal to voltage times the charge. Now we use this since we have this. So the voltage is given 12, current is 2. Now remember, time should be in seconds. Now we are given time in minutes. So we know that 1 minute is equivalent to 60 seconds. So we have 5 minutes x, we cross multiply. So the key point here is whenever you are solving or you are converting time from minutes to second, just multiply by 60. So what is 5 times 6 will give us 30 plus the 0, so we have 300 seconds. So divided by 300 seconds, so it's 12 times 2 times 300. I'm getting 7,200 its energy, so joules. So the answer is this one. Now question 17. The diagrams below show magnetic field patterns between north and south poles of magnets. Okay. Now let's look at the question. So the question is, which numbered diagram shows the correct magnetic field pattern? So what you have to know about the magnetic field lines is the magnetic field lines will always move from a north pole to a south pole. So that's the diagram that we are looking at here. So let's look at one. So one, we can see the arrows. This is not true. So the arrows are indicating that the magnetic field lines are originating from the south pole entering. So this is not true. What of two? Two, we can see that they are coming from the north pole. Okay, this is okay. Then here, also here, coming from south pole. So this is incorrect. Then okay, which number showed the correct magnetic field pattern? Okay, so 3 is incorrect. We can see the arrows, so the answer is 4. We can see that they are coming from the north pole, then going to the south pole, so the answer is just D. Then we move on to question 18. A transformer has 1000 turns on the primary coil. Okay, the voltage applied to the primary coil is 230 AC. How many turns are on the secondary coil if the output voltage is 46? If the output voltage is 46. Okay, so say primary, then secondary. So the primary has 1000 turns. Okay, then how many turns are on the secondary? We don't know. Okay, then let's look at the voltage. The primary or input voltage is 230, then the output voltage is 46. So we can see that here the input voltage is greater than the output voltage, therefore we are dealing with the step-up transformer. So how can we do this mathematics? So let's look at the by what number can we multiply by 230 to give us 46? So let's say we need to divide 230 divided by 46. So this means that this number was divided by 5, because if you get 230 divided by 5, you get 46. So this number was divided by 5 to give us 46. So even this number will also be divided by 5, then will give us the answer that we are looking for. So 1000 divided by 5, you get 200 as your final answer. So the answer is A. Or if you want, you can use the formula. we know that number of turns on the primary coil over number of turns on the secondary coil must be equal to voltage on the primary over voltage on the secondary. So number of turns on the primary is given 1000 over number of turns on the secondary is what we are looking for. Voltage on the primary is 230 over 46. Then we can cross multiply. 230 times ns is 230 ns. Then we have a 1000 times 46. We know that this will give us 46,000. Then you divide by 230. So we know that here you get, if you divide by 230, so according to my calculator, I'm getting 200 as my final answer. So we can say that we are still getting the same number. So whatever method that you may use is, as long as you have to know the proportionality that works under transformer. So whatever number that was used for number of turns will be the same even with voltage. Then with current, it's just the reverse of the two. So if they were dividing by 5, current will be multiplied by that number. So that's a bad pattern under transformers. Okay, question 19. What is the purpose of X plates in a cathode ray oscilloscopy? So the way X rays are these. If you look at the diagrams, they are like this. Then we know that you have this cathode ray oscilloscopy. Then we have the Y plates like this. If you just look at, then there is the cathode, which produces beam of electrons by thermionic emission. So our focus is we want the beam of electrons to move in a straight line until they collide with the powder on the fluorescent screen here, so that we are able to see the image. So if you picture these are X plates. So these are making sure that the electrons move horizontally. So the answer is just B. Then question 20. Sodium nucleus decays by emission of beta particle to form magnesium. Which equation is the correct representation of the decay? So first you need to have an answer, let's say in your brain, before you look at the multiple choices. So maybe let's look at, we are told a sodium nucleus by emission of this. Okay, so we need to look at, okay, for this one, since we are not given the mass number, let's look at the multiple choice to govern us. So we know that under the beta particle, remember that the mass number does not change. So make sure this is true for whatever multiple choice you choose. Then atomic number increases by 1 unit. So this is very important under this decay. Okay, after we're done, we can now look at the first one. A, we have 24, 11. Then we can see magnesium. This is not true, because this one is indicating that they subtracted 4. 24 minus 4 give us 20. 11 minus 2 give us 9. So this is alpha particle. Then the second one, let's look at this one. 24 did not change. Okay, the mass number remains the same. 11 also 11. This is gamma. So whenever it emits gamma, the mass number and the atomic number does not change. Now let's look at our C. C, we have 24, okay, true. 11, no, this is not true. The symbol is quite okay for beta, but the number Z did not change. Then let's look at D. D is our answer, because we can see that we still have let's look at this one. 24, 28 magnesium. How is this possible? 11, 13. This one. First, let me try to look at this one. Correct. So, if we have 11, we are supposed to have at least 12 here. I'm sure there should be an error. According to me, because if we get 24 as the mass number, 11 as the atomic number, then you have this sodium. Whenever it emits beta, the mass number does not change. That is okay. The atomic number increase, so you're expecting to get a 12. So 12 magnesium, then plus this E. So this should be the correct answer. So I don't know what you think of these guys, so you may post your comment in the comment section so that I hear from you, but I think this is what I can see, or maybe it was the typing error in terms of the paper, because I'm not satisfied with the multiple choices that are given. So the answer that is making sense, that is almost there, is C. The only thing is the atomic number did not change here. Okay, we move on now. We go to question 1 from section B. We have figure B 1.1 shows a displacement time graph for the motion of a dog over a period of 12 seconds. Okay, so here we are dealing with displacement time graph, where in the y-axis we are given displacement, then in the x-axis we have time. Now question A, use the graph to calculate velocity of the dog at 10 seconds. So velocity is equal to displacement, which is s, over time. Now time is given 10, so let's use time to find the displacement. So we'll go, time is 10 is here, so we need to move parallel to the y-axis until it touches the curve. So this is our curve. Then we turn 90 degrees to the left. So the point where this line will cut the y-axis is our displacement. So our displacement is 40. And we are lucky that our displacement is in meters, so we no need of converting. So this will be 40 meters over 10 seconds, which is giving us 4 meters per second. Remember, velocity is a vector quantity, speed is a scalar quantity. A vector quantity shows the magnitude and the direction. Now we can move on to question 2, the acceleration of the dog from 0 to 10 seconds. So we know that the acceleration is equal to final velocity minus initial over t. So the acceleration is just the rate of change of velocity. So how fast is the velocity changing over time is acceleration. So the final velocity is just this 4 meters per second, because we are dealing with the same. So it's 4 meters per second minus the initial. The initial we are given it's 0. So the time is giving us the picture since from 0 seconds. So the initial is 0 over time, which is 10. 4 minus 0, we still have 4 over 10. So 4 divided by 10 will give us 0.4 meters per second squared. So let's hope you know how this meters per second squared comes into existence. So let's do this maybe. Let me maybe share this. It may help one to understand here. So we know that acceleration is equal to final velocity minus initial. So let's say we know that the velocity is measured in meters per second over time is measured in second. So what I'm going to do is acceleration is equal to meters. We know that this per same as divide by. You divide. Then this line here, I will just say divided by second. which is we have meters over second. What you do, you convert this into multiplication, then we need to reciprocate this fraction, so this is 1 over s. We know that m times m will give us m times 1 is m, then s times s is s squared. So this is how the units for acceleration comes into existence. So the reason why we have this s squared, second squared, 1 second is coming from the time, then the other second is coming from the speed. Then from the graph, determine the time when the dog is not moving. So how do we tell from a given velocity time graph that an object or something like this is not moving? So you need to look at the line which is parallel to the x-axis. So here we are looking at whatever object or animal that you are talking about has stopped moving. So it stopped moving from 10 up to 12 seconds. So the time elapsed was just 2 seconds. So we'll say from 10 to 12 seconds, which is we can just say for 2 seconds. Okay, now we can move on to question B2. Figure B2.1 is a uniform plank of length 100 centimeter kept in equilibrium. So whenever we have this equilibrium, it means that whatever setup that you are looking at is balancing. So the anti-clockwise moment is equal to clockwise moment. So by a 3 kg and 1 kg mass, place 10 centimeters and 20 centimeters from each end respectively. Okay. Then question A, calculate the Roman number 1 moment of the 3 kg. So what is the formula for moment? So moment is equal to force multiplied by perpendicular distance. Now, how do you do if you are given mass? So whenever you are given mass, you need to convert that mass into weight. How do we convert? So let's calculate weight. So we know that this weight is given by mass multiplied by gravity. So the mass is 3, gravity is 10. So the weight is 30 newtons. So this means that the force that was pushing down here is 30 newtons. So we have our force, which is 30 newtons, multiplied by what's our distance. So this is where our pivot is. So the distance is always considered from the pivot to the point of action. So the point of action is here. So what is the distance from here up to here? We can see that it's 20 centimeters. Also remember to convert distance in centimeters into meters. So that is the appropriate units for a moment. We know that 1 meter is equal to 100 centimeters. So we'll say 20 centimeters, we'll put x, then we cross multiply. So this will give us 100 centimeters x, 20 centimeters meter. We divide by 100 centimeters, also 100 centimeters. So what's our x? X is equal to 0.2 meters. So the simplest way is we know that 1 meter is equivalent to 100 centimeters. So from meters to centimeters, multiply by 100, then the reverse you divide by 100. So we have 0.2 meters. So 30 times 0.2 will give us 6 Newton meters. So this is the moment here. So moment 1 is equal to 6 Newton meters. Okay, then Roman number 2, weight of the plank. How can we find the weight of the plank? So what are we going to do? So let's first look at since we are told it is in equilibrium, so let's first find the moment of this. Let's check if this will give us the same moment. Then we'll be able to see if the Planck played a certain role. So we know that moment is equal to force times the distance. Look at we have given mass, so we'll do the same. Mass can be converted by calculating the weight. So mg, our mass is 1 kg, gravity 10 newtons per kg. So this will give us 10 newtons as our weight. So the force that is pulling down is 10 newtons. Then the distance from the pivot to the point of action is 50. So we know that if we multiply, if we divide, since we are converting from centimeters to meters, if we divide by 100, this will give us 0.5 meters. So if we multiply, we get 5 newtons, 5 newton meters. So we can see that moment 1 is 6 newton per meter, then moment 2 is 5 newton. So we can see that these two moments are not equal. Now we are told this was kept in equilibrium, so there should be another moment, and this moment was done by the Planck. Now how can we find this moment? Okay, so we know that here we have been given a uniform, and this had a length of 100. So we need first to look at where would the center of mass be located on the Planck. So we know that this will be half of this 100. So we know that from here up to where the half will be 50 centimeters, because the half of 100 is 50 centimeters. Now remember, from here, from where the Planck is beginning up to here is 10 plus 20, which is 30. So from here to where the point where the 50, which is half, will happen is just 20 centimeters. So that we know that from here up to here we want a 50 centimeters. So we are trying to divide this Planck into two equal halves. So there was another moment here. So So the distance from the pivot up to where this moment, and this moment, since there was no weight that was hung here, this moment was produced by the Planck, and this will give us now the weight of the Planck. Now let's see how we can solve for this. So we'll say moment 1 is equal to moment 2 plus moment 3. So we know that on the right side we have two moments. Moment 1 will be force 1 times distance 1. Then moment 2 will be force 2 times distance 2. Then plus moment 3 will be force 3 times distance 3. Force 1 will we've calculated this moment, but let's just say we recalculate. So you know that force 1 is 30, distance 1 is 0.2. So we have 30 newtons times 0.2 meters. Then force 2 will consider as now the weight of the Planck. So let's just put W times the distance 2. What is the distance from the pivot to where the half of the Planck is? So we know that is 20 centimeters. So let's take this one as 0.2 in meters. So we divide by 100. So 0.2 plus force 3. We know it's 10. We calculated that. So it's 10 newtons multiplied by 0.5. So we know that this will give us 6 newton meters. Then 0.2 meters times W will give us 0.2 meters W plus here we have 5 newton meters. So we are going to collect the like term, so this will shift to this side. So we are going to have 6 Newton meters minus 5 Newton meters is equal to 0.2 meters W. So this will give us, if we find the difference between these two numbers, we get 1 Newton meters is equal to 0.2 meters W over 0.2 meters over 0.2 meters. So we cancel what is equal to. So let's do calculations. So this will give us if we divide the 1 divided by 0.2, I'm getting 5 Newton. So this 5 Newton was the weight of the plank. So this was the force produced by the plank. As a result, we have now a balanced setup. Then B, step 1, application of the above setup. So there are so many applications of moment. The first one, we can say seesaw, then like opening. When you open a door, moment is applied. When you open a window, moment is also applied. Tightening or loosening of a nut, moment is applied. Then we can just say etc, since there are so many applications. Then also in some classes, because we know that we have 3 classes of machines where we have the first class, second, and the third. So you just have to look at the arrangement of load, effort, and pivot. So that is you can identify and you'll be able to see. Now we move on to question B3. Figure B3.1 is a diagram of a spring catapult designed by a pupil for a science project. The catapult consists of a movable plunger with a spring attached to it. Okay. So we have the ball here. So then movable plunger, this one, then spring. So the whole thing is you just have to push this down. Then as you are pushing, the spring will be compressed. Then if you let it go freely, then this spring will force the ball to move up. Now let's look at the question. So a metal ball of mass 0.2 kg was placed on the metal plate and the handle of the catapult pulled to fully compress the spring. Okay. On release, the handle, the ball was projected 1.5 meters vertically. So we are saying if this metal plate here is pulled down where our spring is now compressed somewhere here, then we know that there is a force that is being applied, which is pulling the spring down. There is also the force that will be pulled by the same spring. If you now let it free, if you let this one to go freely. So the point here is, after you let this one go freely, it moved from this point to where it reached with a vertical height of 1.5 meters. So you know that if we have this height and the mass, we can now find the question B. We can see that question B is calculate the the maximum potential energy required by the ball from the catapult. Now let's look at A before we look at B. Name the type of energy stored in a compressed spring. So it is potential. So potential elastic energy. Then we move on to question B. Calculate the maximum potential energy acquired by the ball from the catapult. So potential energy will be given by mass times gravity times height. Then our mass is 0.2, gravity is 10, height we are told it projected 1.5 meters, 1.5. So say 0.2 times 10 times 1.5. So 0.2 times 10 times that is giving me 3 joules as our potential energy. Then give one reason why the potential energy you have calculated B is less than the original stored energy of the spring. Now, the reason why after the spring is compressed and allowed to go up freely, it is not all the energy that was being transferred onto the ball. So some of the energy may be changed into another form. We know that energy cannot be destroyed but can be converted. So some of the energy was converted into maybe a sound. If that spring produced a sound, so that sound came from the same potential energy. So it's not all the energy that was transferred onto the ball. Thus we have a reduction of energy. So we'll say not all the potential energy was transferred to the ball. Then we move on to question 4. For question 4, figure B4.1 is a diagram of a block and tackle pulley system used to lift a load of 200 kg. Okay. And let's look at we have this setup. Then state the velocity ratio of the pulley system. So VR is equal to, here you have to count the number of ropes. So we have 1, 2, 3, 4, 5, or you can just count the pulley. We have 1, 2, 3, 4, 5. So our velocity ratio is just 5. Let's move on to question B. If the machine has an efficiency of 80%, calculate the effort applied. Okay. So we know that mechanical advantage is equal to load over effort. So for us to find the effort, first we need to find this mechanical advantage. So how can we find mechanical advantage given the efficiency and the velocity ratio? So we use this formula. Efficiency is equal to mechanical advantage over velocity ratio times 100%. So there is this efficiency, we put 80. So 80% is equal to mechanical advantage is what we are solving for. Then velocity ratio is 5 times 100%. So we can see that 5 here is 1. 5 here will give us 20%. So 20 times MA will give us 20% MA. Then is equal to 80%. So let's divide by 20%. 20%. So mechanical advantage is equal to 4. Remember, as long as the efficiency is not 100%, mechanical advantage should be less than velocity ratio, and it's making sense. 4 is less than 5. So we have the mechanical advantage, which is 4. So that's what we are going to put here. So this is 4 is equal to, let's go back to our diagram so that we see the load. So the load is this. Now remember, load must be a force. So what can we do? So let's calculate now the force. So we know that weight is equal to mg. Then the mass is 200, gravity is 10. So this will give us a weight of 2000 newtons. So this 2000 is our load. So whenever you are given mass and the formula needs to find load, please remember to calculate the weight. So you have a 2000 newtons over E over 1. We cross multiply. So we'll get 4E is equal to 2000 newtons. So we divide by 4, also by 4. So that is a 2000 divided by 4. So I'm getting a 500 newtons as an effort. Remember, the effort must be less than the load, because if the effort is greater than the load, then this setup is not making sense, or is not qualifying to be a machine, because a machine is designed to make the work easy. So let's move on to question 5. Figure B 5.1 is a graph of how a wave is propagated. Okay, so this is a transverse wave. Then we have displacement in the y-axis, time, displacement in the y-axis. Then we have distance in centimeters in the x-axis. So let's look at from the graph. Determine the first one, the amplitude of the wave. So let's draw a rest position of these lines, this wave. So this is our rest position. If this is our rest position, the distance from the rest position to the peak of a wave is what we call the amplitude. So you can say that if this is 0 and the height is 15, so the amplitude, you just get that number. So the amplitude A is equal to 15 meters. Then wavelength of the wave. So we know that wavelength is just the distance covered by one wave. So if, let's put maybe some letters. So let's say A, B, C, D, E, F. So let's pick two letters that we think is making one wave. So it's A up to B. So the distance from here up to here makes one wave. If you want, you can start from the distance from here up to here will make also one wave. So if we start from A, we know that A, if we move down, our A is what? 0. Then our C here will give us a 60. So that's our distance. Then if we begin from here, we know that if we go down here, you are getting a 15. Then here we'll get a what? A 75. So you find a difference. 75 minus 15, you still get 60. If you want, you can take it from here. 45 also here. You get 105. So 105 minus 45, you still get 60. So the answer here is just 60. So wavelength is equal to 60 centimeters, which is in meters. You divide by 100. This will give you 0.6 meters. Then calculate the frequency of the wave if it travels at 3 meters per second. So you know that velocity is equal to frequency times the wavelength. So we want frequency, let's divide by lambda, also by lambda, so that our frequency is equal to velocity over lambda. So velocity is given this speed, 3 meters per second. Then wavelength, we've calculated this number, so over 0.6. So 3 divided by 0.6, you get 5. So we have 5 Hz. Okay, so we can now move on to question 6. So figure B6.1 shows a perspex disc fitted on a wooden stand. Okay, so we can see that here we have a neutral perspex. Then we are told when rubbed with far, electrons move from the perspex disc to the far. Okay, so this one gives. So if this gives it, then the perspex developed a positive charge, the far will gain a negative charge. So here, if you look at the static electricity, it has to do with the movement of electrons from one substance to another substance. Remember, the substance that loses electrons attain a positive charge in the process, while the one that gains electrons will form a negative charge. Then question A, what charge is induced in the perspex disc? So it's a positive charge. Then state the unit in which charge is measured. So this is coulomb. So coulomb or coulombs. Then small pieces of paper brought near the perspex disc stick to it. Explain why. So whenever we have stick is same as they were attracted. So for us to have attraction, we need to have two substances of different charges. So say because the papers had charges which were opposite, opposite to the charges of perspex. Thus, we have now force of attraction. Then we have this question. When a polyethylene rod was rubbed with far, it was able to attract small pieces of paper too. Name the type of charge induced in the polyethylene rod, and explain using the movement of electrons how charge was induced. So here you need to look at what happens whenever you rub a polyethylene with far. So the polyethylene this time will gain electrons, so it will gain. So if it gains electrons, this will form a negative charge. So explanation, the polyethylene gained electrons. So gained electrons, as a result it forms negative charge. Then we have this question. Figure B 7.1 shows the circuit diagram connected to a 12 volts supply. Okay, then calculate the combined resistance of the 2A and 3A. So this is, we'll consider this one as resistor 1, here as resistor 2. So we can see that the switch is open. So this means that this resistor is disconnected. If this resistor is disconnected, no current is passing through resistor 6. If that is the case, then we are dealing with the two resistors connected in series. So how do we find a combined resistor? It's simple. So say total resistance is equal to resistor 1 plus resistor 2. So resistor 1 is 2 ohms plus resistor 2 is 3 ohms, which is the total is 5 ohms. So when the switch is open, the total resistor is 5 ohms. Now total resistance in the circuit when the switch is closed. So if we close this switch, Then we'll first have to look at the total resistance of the two resistors connected in parallel. So what is this? So we have 3 and 6. So we know 1 over RT is equal to 1 over R1, R2. So 1 over RT, we know one has 3, the other one has 6. So what is our lowest common denominator? Is 6. 3 into 6, 2 times 1, that is 2, plus 6 into 6, 1 times 1, 1. So 1 over RT is equal to, here we have 3 over 6. We cross multiply. 3 times RT will give us 3 RT is equal to 6 over 3 over 3. So for the two that are connected in parallel, the total resistance is just 2 ohms. Then for those that may be used or familiar with this formula, so you can say RT is equal to R1 times R2 over R1 plus R2. So which is R1 is 3, R2 is 6 over 3 plus 6, which is 3 times 6 will give us 18, 3 plus 6 will give us 9. 9 into 18 we get 2 amps. So this, 2 ohms. This 2 ohms is the combination of these two. So this means that the remainder, if the switch is closed, is like this. So we have combined the two resistors. Here we have 2 ohms and the 2 ohms that we formed. So this is giving us now that the total resistance of the circuit will be RT is equal to 2 plus the combined 2, which is 4 ohms as our answer. Then the potential difference across the two resistors. Now for this one, we don't know if the switch is closed or open, but let's take it the switch is, since they have not mentioned, let's just say the switch is open. So if the switch is open, we know that the remainder of these two is in series, and we've calculated total for that. So we'll say voltage, let's first find the current. So current is equal to voltage over total resistance. So for the two that are connected in series, if one is disconnected, that one gave us a 5, and we know that the total voltage is this number 12. So it's 12 divided by 5. So if we get 12 divided by 5, then we have 2.4 as our current. So where is this 5 made for? Maybe someone may be behind. So the 5 is coming from, if we add this resistor and this, since this one is disconnected. So if I were to redraw, what is happening here is this. So I'll just get the two resistors. So we have removed the one since the switch is open. So we know that the first one is 2 resistors, then the other one is 3 resistors. So the question is, we want the potential difference across the two. So we know that these two are connected in what? Series, and current is constant in a series connection. So this means that the current that is passing through 2 ohms is the same with the one that is passing through 3 ohms. So let's find the voltage that was used here. So say voltage is equal to current by resistors. So what's our current? Is 2.4 times the resistor is this 2. So we have 2. So 2.4 times So we have 2.4 times 2, we have 4.8. So 4.8 volts was the one consumed, because we know that the total voltage is what? 12. So from that 12, 4.8 is used by this. So that's a pattern. Okay, so now let's look at now total current flowing in the circuit when the switch is closed. Okay, so here we'll say current is equal to voltage over total resistance. So the voltage is 12. Total resistance. Now we need to get the total resistance for the whole circuit when the switch is closed. We calculated this to be 4. So we divide by 4. Then we can see that here we have 3 amps. So 3 amps is the current that is passing through the circuit if the other switch is closed. But if the switch is open, the current we calculate to be 2.4. So let's move on to question 8. So question 8, we are told figure B8.1 shows a diagram of an ion core electromagnet. So here it's just like a setup that they use to make an iron ore to turn it into a magnet. So state 2 ways in which the strength of the electromagnet in figure B8.1 can be increased. So we can see that these are like the coil, so these are turns. So the first one, you increase the coil, or we say the turns on the coil. So that is our first one. So this means that if we have 2 setup, we can see, then we have another one. Then for if this is our A and this is our B, for the second one we can see it has a greater number of turns. So for B, the strength of the magnet will be greater than for A. So that is the point. Then the other one, increase voltage, or we can say increase current is the same answer. So if this for A, if you are using 12 volts, then B you are using 240 volts. The magnet that you are going to produce by 240 will be stronger than the magnet that you are going to produce by 12 volts. Then we go to B, explain why the core of the electromagnet is made of iron instead of steel. So we'll say iron easy to be magnetized and easy to be demagnetized. That's the reason we give here. Then for question 9, figure 9.1 shows a decay curve of a radon nuclide. Okay, then let's look at the question, define nuclear fission. So there is nuclear fission and nuclear fusion. Fusion has to do with joining, fission has to do with splitting. So say this is the splitting of unstable atom of an element. So of an element after we say bombarding or after colliding with a neutron. But the whole thing is here is just about the splitting of unstable. Then during nuclear fission, energy is produced. Then from the graph, determine the original mass of the nuclide. So before it started decaying. So how do you get that? So mass is in a y-axis. So this point where this curve is touching the y-axis indicates the original mass. So this is why you get the original mass. So our original mass is equal to 80 kg. Then the quantity of the nuclide that remained after 6 days. So let's go back to our graph. So days were in the x-axis. So 6 days is here. So you draw a line. Then you turn 90 degrees to the left. So we can see that we are cutting the x-axis at 10. So 10 kg remained after 6 days. So we'll say 10 kg. Then Roman number 3, which is the last one, half-life of the nuclide. So half-life, how do we calculate half-life? So half-life is half multiplied by original mass. So what is the original is 80. Half of 80 is 40. So this 40 is not a final answer. So we'll go in the y-axis. Let's look at where this 40 is, this number. Then you draw a parallel line to the x-axis. Then after touching this, you move down toward the x-axis. So you can see that this is falling at 2. So after 2 days, the half of that substance was decayed. So the half-life is 2 days. So this is what I wanted to share with you guys on this video. Thanks for watching.